Example 31, to solve this, we need to get log of 5x alone first. Make sure you don't accidentally think that it says 5x minus 3 in parentheses because you'll get the wrong answer. If there's no parentheses, don't assume that they're there. Add 3 to both sides, we'll have log base 10 of 5x equals 5. Then we're going to take this logarithm and we're going to change it into exponential form. 10 to the 5 equals 5x. 10 to the 5 is really a 1 with 5 zeros, or 100,000. 100,000 equals 5. Divide both sides by 5. 10 over 5 reduces to 2. X equals 20,000. Example 32, we're solving another logarithmic equation. Make sure you recognize that we have a log base 10 because of the common log, no subscript written, and we could also use quotient property. This way we can consolidate our left side down to a single logarithm, which is super important. When we use the quotient property, we'll have log of 2x over 8, which reduces to x over 4, equals 3. Again, like mentioned before, we really have a base 10 to that logarithm, and we're going to rewrite from logarithmic form into exponential form. 10 to the third equals x over 4. 10 to the third is a 1 with 3 zeros, 1,000. 1,000 equals x over 4. Multiply both sides by 4, and x equals 4,000. Number 33 is another logarithmic equation to solve. On the left-hand side, we're going to use the product property and rewrite that as log base 7 of x plus 2 times x. X plus 2 times x is x squared plus 2x. Here, we are able to use the one-to-one property because we have log of this equals log of that. Therefore, this must equal that. What is this? X squared plus 2x. What is that? 24. Once we have the equation x squared plus 2x equals 24, we're really now working with the quadratic equation. Quadratic equations, like all polynomials, should be solved by having the equation set equal to 0 and then to try factoring. If factoring doesn't work, there are other methods, but factoring does work in this example. This factors into the two expressions x plus 6 and x minus 4. If you need to do that work on the side, press pause and work it out for yourself now. After you have your quadratic factored, we're going to use the zero product property and set each of those two expressions equal to 0 and solve for x. We get that x equals -6 and x equals 4. Before moving on, we should realize that this is definitely a good example to check our domain. You're never allowed to take the log of 0 or a negative number. We're only allowed to take logs of positives. Once we set both expressions that we're taking the log of that have x's in them from our original equation greater than 0 and solve, we see that our domain is x is greater than 0 and x is greater than -2. Since -6 is neither of those things, it will be excluded from our solutions, and our only answer is x equals 4. We're going to start the next example by using the power property to put both those 3's back away up as exponents. ln is still log, so logarithmic properties still apply. It's just special, and it's the natural log. Logarithmus naturale from Latin. ln of 3 to the third plus ln of c to the third brings us to the next line of ln 27 plus ln c to the third. Addition makes us think product property, and our final answer is the ln of 27c to the third. If you were able to follow example 34, you really shouldn't need to have as much guidance on number 35, as it is quite similar. The main difference is we're going to be using quotient property instead of product property. If you wanted to solve a question like number 36 in a quite robotic way, you'd probably just use the power property to bring 3 out front. Then you're left with ln e to what power is e? 1. The answer is 3. However, there is a way more practical method that you could utilize. Whenever you simplify the natural log, or ln of e to a power, the quick thing to remember is the answer is just the power. The question really reads as log base e of e to the third, which states e to what power is e to the third? That question should really answer itself. Think about it again. E raised to what power will equal e raised to the third power? 3. The answer is 3. So again, anytime you have the natural log of e to a power, it simplifies down to that power. On number 37, we already have the log of one solid expression equal to a number that is perfectly set up for us to change it from logarithmic form to exponential form. E to the 8th equals 2x minus 1. Add 1 to both sides, e to the 8th plus 1. Divide by 2 or multiply by 1/2, and we have x alone. All you need to do is punch this in the calculator to get the decimal solution. The precise answer would be e to the 8th plus 1 all over 2. That's accurate, precise, exact. The calculator gives us an approximate solution of 1,490.97899, yada yada yada. Choice D. ln of 2 plus ln of x, we can rewrite as ln 2x using product property. Now that we have the log of something equals a number, we can change this from logarithmic form to exponential form. E to the 5th equals 2x, divide both sides by 2, and then employ your calculator to get the decimal solution. This next example is very similar to the last example. Two main differences. One, we're going to use the quotient property instead of the product property. And two, we have a 0 on the right side of the equal sign. Zeros can be tricky for people, so don't forget when you get to the step where you are going to write e to the 0 equals x over 6, that any number to the 0 power equals 1. Don't accidentally put a 0 there, and everything should be fine, smooth sailing. Also, they don't ask us to round the solution, so that means that we leave our answer just the way it comes out, solving by hand. Whenever we solve any exponential equation, the first thing you really have to focus on taking care of is isolating the base to the power. We're going to approach this by adding 2 to both sides and then dividing both sides by 6. After that, we'll have an exponential equation where we just have a base to a power equal to a number. This means take the ln of both sides. We just saw a few minutes ago, ln of e to a power is just that power, so we'll have the ln of e to the 4x equals ln of 5 over 6. The left side becomes just 4x, the right side, ln of 5 over 6. Divide both sides by 4, use your calculator, and you'll get your final answer. We just did an example like this one, only the last example had several more steps before we could take the ln of both sides, so this one should be pretty easy to just follow the work. The same goes for the next example. We're just going to take the ln of both sides. ln of e to a power is just the power. 2x equals ln of 1.4. Divide both sides by 2, bust out your calculator, and that is that. 3 ln 5 plus ln x, written as a single natural logarithm. 3 is going to go up and be the exponent on my 5 because of the power property, ln of 5 to the third plus ln x. Next we use our product property, 5 to the third times x. 5 to the third is 125. We'll end up with the ln of 125x. Let's isolate the e to the negative 2x first. You're going to do that by subtracting 5 and then dividing by 3. After you do that step, you're going to take the natural log of both sides. ln of e to a power is just that power, and the other side will have the ln of 6. Then we'll divide both sides by -2 for our final answer. To get any decimal values, use your calculator. For this next word problem, you should be able to identify that the initial value, P, is going to equal 895 wolves. We're increasing at an annual rate, R, of 7%, so R is really 0.07. We just want to know which of the following functions models the wolf population, and we'll just use A equals P times the quantity of 1 plus R raised to the T to figure that out.